Good afternoon, everyone. Thanks for joining us for today's event on consideration of carbon neutrality on green deck design at the library or participating online via Zoom. I'm the MC today, Ken Chen from Green Deck Project Management Office. Today's event is co-organized by our office and the library with support from ARUP and Morocco, which we aim to introduce Green Deck project to all PolyU staff and students. For today's rundown, it is our great honor to invite Professor Christopher Chao, Vice President of Research and Innovation PolyU, to provide opening remark. We will have two numbers of featuring speaker, Mr. Alex Lui from Green Deck Office to introduce Green Deck design and Dr. Pooh Strong from ARUP to discuss on the topic of carbon neutrality consideration on Green Deck design. Followed by speakers' presentation, there will be Q&A session. Before we start with the great program this afternoon, may we first invite Mr. Alex Lui, Project Director of Green Deck Office, to give us the welcoming speech. Welcome, Mr. Alex Lui.
Thank you, Ken. Welcome, everyone, to the library this afternoon. This is my first time to use a beautiful one like this. I think in this environment, a new floor of this library is really wonderful. I don't expect the library could be such open space and with a variety of character in each part of the library. I think that would really improve the learning environment and help our students to use their minds in a more flexible and vigorous way. So we look forward to a lot of interesting activities at this location. This is my first time and I really enjoy it. Today, I would like to welcome all of you to spend your lunch hour with us on this topic. The topic of Green Deck, I'm going to talk about it a little bit later, so I'm not going to repeat it. But there's one very important feature that we have incorporated into the design, which is about the carbon neutrality of all buildings. And we like the expert in this area, Dr. Chong, later on to share with us all his thoughts has been given on the carbon neutrality issue on this project. And we really look forward to learn a lot from him today. At this point, maybe I would like to invite our Vice President, Professor Christopher Chao, to give us the opening remarks.
Alex, Bruce, Shelley, distinguished guests, ladies and gentlemen, good afternoon. Thank you very much for inviting me to give an opening remark for today's event, forum on consideration of carbon neutrality on green deck design. We all know climate change and high carbon emissions are among the world's biggest problems nowadays. To help achieve carbon neutrality at PolyU and support Hong Kong's goal of reaching carbon neutrality by 2050, PolyU is working on a roadmap in fostering a greener and more sustainable campus. In fact, our university has set a goal to achieve carbon neutrality by 2045, 5 years ahead. So we are facing a lot of challenges, but it also gives us a lot of opportunity to do something for the betterment of society. PolyU has been strengthening on our university's research capabilities and to continuously explore new and pioneering approaches to help Hong Kong achieve our carbon neutrality goal. The green deck to be built right over the Hong Kong Cross Harbour Tunnel Toll Plaza would be a unique and innovative social project that will bring long-term benefits to our society. Besides providing a landscape park to enrich urban living, it would help to improve air quality and upgrade the environment in surrounding neighborhoods. It is also anticipated that the Green Deck would enhance the pedestrian connectivity among nearby districts and act as a catalyst for building a vibrant community. Other than the benefits mentioned above, I'm glad to learn that the Green Deck study has taken a proactive approach to address the carbon neutrality issues. The latest Green Deck design had incorporated many sustainable design features. For example, adoption of sustainable building materials, integration of renewable energy, provisions for future seawater cooling, carbon sequestration, and biodiversity in landscape planning, which would help to achieve carbon neutrality and to benefit the environment substantially. I'm very delighted that our distinguished guest today, Dr. Bruce Chong from ARUP, will speak to us on his insights on carbon neutrality and its applications in the Green Deck design. Dr. Bruce Chong is responsible for the sustainability design of our Green Deck study. He would elaborate on how to bring cutting-edge knowledge to bear on practical construction to benefit our environment. So I believe all of us will learn a lot in his presentation, and we look forward to useful ideas raised among our colleagues in the Q&A sections. So may I take this opportunity to thank you all for joining this event today. Without any further ado, let's start the forum now. Thank you very much.
Thank you, Professor Chao. During the event, you are welcome to share your views by scanning the QR code showing on the screen. Now, may we invite the first speaker, Mr. Alex Lui, to give us presentation. Mr. Alex Lui, please.
Well, thank you again. Thank you again. Today is about the main topic would be on carbon neutrality and how to apply the knowledge in carbon neutrality on the design of a building, which is Green Deck. I would like to begin by say a little bit about what the Green Deck is, so that you know the building itself. And then later on, Dr. Chong would tell us how would he apply the knowledge of carbon neutrality on the design of this building, the Green Deck. Well, there are two images on the screen. The left one is the existing condition. As you know, this is the Hong Kong Cross Harbor Tunnel toll plaza, which you can actually look at the actual site if you walk over there and look down from the window. It's a big piece of land full of cars during most part of the day. The area is about 4 hectares. But because of it is the Hong Kong Cross Harbor Tunnel, it attracts a lot of cars, over 110,000 cars per day. And with this amount of traffic, you can imagine the kind of pollution and noise and dust generated. So it has caused considerable problem to our environment. This area, other than full of cars, it is also full of people. The building next to the toll plaza is the Hong Kong Railroad Station. That is one of the most busy stations in Hong Kong. Every day, more than 200,000 passengers would pass through this station or use the station. And in addition, there are about 80 to 100,000 passengers that would come by bus And then there would be another 80,000 people that lives or works or study around this area. And just our PolyU itself has a population of over 30,000 students and staff together. So there are almost 500,000 people moving around this area. But as you can see that most of the space on the ground has been taken up by traffic. The pedestrians really have no space for them on the ground. So they are squeezed onto two very narrow footbridges, that one and this one, and they can only walk from one side of the bridge to the other side and cannot really go much further out because it's a big confusion here. If you walk on the street, sometimes your pavements disappear and you don't know where to go. You may be able to see what is in front of you, but you won't be able to get there very easily. For example, we do have the harbor not too far from our campus, but if you want to walk to the harbor, it's quite a difficult thing. So the pedestrian connectivity has broken down in this part of this city because of the amount of space has been taken up by the traffic. Our university will be here forever, for a very long time. And so would be the Cross Harbor Tunnel. So early in 2010, the university thinks that we have to do something. We have to find a solution, how to mitigate or resolve all these problems. And that's the time that we developed the green deck idea. The green deck is really a big structural deck that would cover the whole harbor tunnel toll plaza, except this portal, open portal area that we cannot cover. So what you have seeing here is about 3 hectares of land or deck area. The structure would consist of 3 levels. The first level would be left for the Cross Harbor Tunnel traffic. But we have proposed 2 indoor bus waiting lounges on the ground floor. All the pedestrian traffic would be lifted above the ground to the intermediate level and the deck level. The intermediate level would be an indoor pedestrian concourse, plus some community facilities. And the deck level will be used entirely for a park. That's a general idea of the green deck. When it is done in this way, all the polluted air on the ground floor will be collected, we hope, and treated with all the pollutants removed before releasing to the air. And the pedestrian will be walking on a level above. Above the traffic on the intermediate level and on the deck level, so that there will be vertical separation of the traffic and the pedestrians. This idea has met a very good support from the community. After we have shown our very preliminary feasibility study to different sectors in the society, we have worked very hard between 2014 and 2019 before we have the support of the government, and we have got a grant from the Hong Kong Jockey Club, a charity trust, in order to carry out a project development study in 2020. And now this study is about to be completed. When it is done, you can see that with the exception of the vehicular traffic, will still be remain on the ground level. The pedestrian will be lifted above the ground, and they will be able to walk from the PolyU campus, from our pedestrian podium onto the green deck, and then onto the Hong Kong Plaza podium. So with this connection, the people could walk around in all this neighborhood around the green deck and be connected to each other. And when this happened, we can see that there are 3 major corridors being established. We understand the Hong Kong railway station may be redeveloped in the near future because the East Rail and the West Rail has been moved out from their old platform. On this side, what we see is the establishment of what we call a knowledge corridor, where the high-tech research could merge with the business and the industry people on the other side. And then in the middle, there is the cultural corridor, which connect the Hong Kong Coliseum to the museum groups on Chatham Road. And there's a third corridor, which is even more important, which is a green corridor leading onto the harborfront, Hong Kong Bay. Now, these 3 corridors intertwine with each other so that the pedestrian traffic can really circulate freely around all this neighborhood and make all this entire neighborhood very vibrant. And with the green deck there, it's not only vibrant, it is also a much greener neighborhood that we will be creating in future. The green deck has 4 goals, 4 objectives. The first one is to improve the air quality. Now, I've just said the deck would cover up the toll plaza and suck away all the polluted air, remove the pollutants so that the air will be purified before they will release back to the atmosphere. The second objective is to restore the community connectivity. Those are the corridor idea that I just mentioned about. And thirdly, because the intermediate level of the green deck still has a lot of space that we could use them for all kinds of community use to serve the community needs. And also the park itself would serve as a green space for the surrounding area. And the fourth, in fact, is one of the very important objectives is about the local economy. Now, if the environment could be improved so much, we believe the neighborhood would actually appreciate in value, and more business will move on to this area, and people will be living in a much nicer environment. In order to show that the green deck can really achieve these goals, these are some of the studies carried out by our consultants. As you see that this top sketch shows how the polluted air could be spread around this Hong Kong area and the toll plaza area. All the red color and the yellow color area would be area covered by the polluted air. But once the green deck is put in place, as you can see, that the polluted area would be greatly reduced. This is generated from a computer modeling method. All kinds of ways would be introduced in order to achieve this result, including an air purification system. This is the large system that would be responsible for cleaning up the air, and also some smaller scale air purification system that could deal with a local situation. The second one is to restore the community connectivity. I've explained how the Green Deck could connect up with our PolyU campus, the Tsim Sha Tsui East area, and the Kowloon Station by a series of these bridges that would connect to all the neighboring developments. So wherever you want to go as a pedestrian, you don't have the problem of walking among the traffic. Now it's all pedestrian, very safe, very convenient, and very beautiful if you walk through the park. And through this system, you can get to all these places around the Green Deck. We have said that there are still space on the intermediate level that could be used for all kinds of community purposes. For example, here is the park on the deck level. This is the top level, and that would be where the park would be at the entrance of our PolyU entrance. Now the exit A, I believe, from the MTR station. The middle part shows all kinds of cultural, educational, and social activities that could be accommodated in the intermediate level. And the last two slides shows how the indoor bus waiting lounges would look like on the ground floor. So when you wait for the bus to come, you don't have to wait under the sun and suck in all those polluted air anymore. From the air, you can see that the Green Deck is really in a very central place among all these areas: educational, commercial, sports, and then residential. So once the Green Deck has been built, the environment would be much enhanced to make the center part a very desirable place. And we can see that this kind of good influence could overspill onto all the neighboring area. And we can see that the Green Deck could act as a catalyst to bring about improvements to all the neighboring neighborhoods gradually. The Green Deck has 3 levels, I've just said. On the ground level, it will serve the cross harbor traffic, and on both sides, it would be the bus waiting lounges. So you wait for the bus, the door would be open when the bus arrives, and you just go out and board the bus. But while you wait for the bus, you don't have to breathe in all this polluted air. The middle part is for the pedestrian concourse, the all-weather indoor pedestrian concourse that for people to walk from one part of the site to the other one. And the top level would be the deck, urban park. Again, it's a pedestrian-dominated area. This you will see the use of the site in the sections as shown in the model. Further down, on the ground floor, the cross harbor traffic will use the middle part of the site for the traffic because of the introduction of the free flow toll system. We'll be able to reduce the amount of driving lane in order to create the 2 indoor bus waiting lounges on both sides of the Green Deck. This is for southbound buses, and that is for northbound buses. Now, the operation of this bus waiting lounge would be similar to Yumenfang in Guntong, and that's an interior view of the bus waiting lounge. On the intermediate level, now there will be, other than the gray area, which are the plant rooms for the air purification systems, the rest are usable area. The yellow area would show the indoor pedestrian concourse. The orange area would be for retail uses, and the pink areas are the food and beverages or refreshment establishments, leaving all the green area for all kinds of pedestrian activities. So this would be a pedestrian concourse and community facilities level. Again, this is the entrance to PolyU on this side, and on this side is the green deck. And there will be a small entrance plaza incorporated in the green deck in future, making the entrance to PolyU a more grander plaza than today. This would be the entrance to the PolyU entrance in the north. That's the interior side of the intermediate level, showing some of the community, educational, or social activity space and the pedestrian concourse. And that's the landing between the deck level and the mezzanine floor. On the top level, the whole of top level would be used for a park. Now, with only this part kept open, that's the open portal area, which allow the polluted air from the tunnel to be exhausted into the air. We cannot cover this part, and the rest of the site will be all covered by the green deck. It will be used for a park that will serve all kinds of people. Now, as you can see, that the design of the park has divided into areas, and each area would have a different character, some for older people, some for young people, and some for kids. And at the end of the south end of the park, we have an islet. This is a small building which kind of rise over the harbor front and overlooking onto the Victoria Harbor. Different areas on the park would have different characters. They have been divided into this 8 areas to serve different social groups. And we all hope that one day the green deck would become a reality. This is the end of my introduction to the design, and may I invite Dr. Chong to come out to share with us his insight on the carbon.
Thank you very much. Thank you for the invitation from Professor Chao and Shelley and all PolyU's colleagues. My pleasure here to be on behalf of the project team, so Alex, Maxer, and Wilfred, to share with you our collective work behind the scene, what we have been thinking on carbon emission and carbon neutrality for this project. Okay. I know I can't keep you for too long because it's already 1:30. And a lot of you may be starving, and so I don't want to bore you for too long and keep it sweet and short. But I understand, appreciate a lot of colleagues work a lot on carbon neutrality, put a lot of thoughts behind. So we'd like to share a little bit in layman terms, what will drive us to incorporate more technologies and innovations, and especially to steer more our research work behind this project. A quick overview, explain a little bit concept on carbon, and basically we have the design, as explained by Alex, our design. So based on this as designed case, what is the carbon emissions? And then we have some more ambitious thinking, so more
advanced measures or more sophisticated measures that could be incorporated, and what would be the amount of carbon behind. So the third part, and we will talk a little bit about the underground, the air purification systems as well. So quick overview. This is sort of some key terms that we use interchangeably. So everybody, in the old days talk about low carbon, carbon reduction, and then moving towards a lot of terms on carbon neutrality, and people use it as well. Net zero carbon and zero carbon. We have a zero carbon building in Hong Kong, right? And negative carbon. So it can be simply explained in this basic diagram. As you see in the red line above, business as usual, BAU. BAU, if we do nothing, basically is the trend, right? Up and down, so in the top. Now we are moving towards no carbon. So basically every companies, every person, the government, they are moving towards low carbon by reducing the amount of emission. So basically we can remove the carbon emission, basically the gray part. So it's the reduction in terms of absolute term. And then we could have the blue part. So meaning we have the reducing trajectory of the carbon emissions. So the blue part here represents the gross emissions, right? The emissions down the road from now to 2100 to the end of this century. And ideally, if we can, remove all carbons as quick as possible to this point, this will be the, the ideal case, as quick as possible, right? But it's not the ideal world. So basically, we will endure all the way through the end of century to have emissions, right? But in the meantime, we can, with those, or offset, use as another term, offset this emission by carbon removal. So the green part. The green part, basically, we can do, carbon absorption or removal by plantation, by greenery, or by soil, or by some mechanical system, carbon sequestration by actually removing carbon directly from the atmosphere. So basically, if we, add up together, if this is at this point, this can be called carbon neutrality or carbon neutral or net zero carbon. There's some subtle difference between the second and the third term. Carbon neutrality, the focus is more on neutralize, the positive and negative. You can use different means to achieve that, by purchasing carbon credits or use other means, on procurement to achieve this. Whereas net zero carbon, the focus is more on the term zero. So meaning you directly use zero energy, right? Basically use renewable to offset every emissions. So as a whole is net zero. So the focus is a little bit different. More companies, they intend, or even the government, they intend to use the second term. It's more flexible. And the fourth term is very obvious. Zero carbon, basically everything is zero carbon. So basically if your wash are using solar power without any battery inside, just driven by solar energy, basically is zero carbon, right? Without any offsetting. So zero carbon is basically the ideal case without any other fossil fuel use. So we get rid of the fossil fuel economy, meaning the fourth term. Negative carbon, if we can achieve, beyond this point, the amount of removal more than the emissions, basically we can achieve this line. So basically everything beyond this line, negative carbon, right? Okay, just a quick, intro about, the key concept. Another key concept is around the life cycle assessment. So you heard a lot, I suppose, in your course, no matter you're in engineering or management, etc. You will come across a term called LCA, right? Life cycle assessment. Now, when we talk about carbon emissions, so Hong Kong's people, every year we have around 5. Now it's 4.37 in 2021. Per capita emissions in Hong Kong is 4.37, yes, last year. Now, but this emissions basically, say, Bruce in Hong Kong emit 4.2 or 4.3. What does it mean? It means my emission in Hong Kong, so my energy use, my water consumptions all attribute to the carbon emissions in Hong Kong, within Hong Kong. But actually, when we talk about life cycle assessment within the project, it's not only implying the emission in operational stage. Right, when we have PolyU, every month we need to pay electricity bill, the tariff, all contributes to emissions. But it's not only in this stage. Basically, when we are talking about the whole life cycle assessment, we need to consider the upstream, the downstream. So upstream meaning we also need to be on something beyond our site, something beyond our site, not in situ, but also the emissions due to material use. The materials, basically, they also have a lot of emissions because of material extraction, transportation, production, etc. So in the upstream, there already been a lot of emissions. And similarly, even during operations, we could have a lot of replacement, refurbishment, so operation and maintenance. So what we call in terms technical jargon, sort of operational embodied and upfront embodied carbon. A lot of engineering people, they're now talking about this term, especially the company guys, if they consider ESG, they are forced to deal with this sort of embodied carbon upstream and also downstream. When we are talking about decommissioning a project, we also need to consider those downstream carbon. So why we need to consider not only the operational stage, but also the whole life cycle assessment, because simply speaking, we have the influence, we have the control as an organization over the material use or the selections also are designed. So as simple as that. So a lot of companies, they are now being pushed to consider this, not only during the operational, not only the lights, the extract, or, my cars during operation, but also upstream, downstream, the whole life cycle, which we call indirect carbon or embodied carbon embedded in the supply chain. All right. So this is sort of quick review of what we're talking about carbon. So key concept, right? We need to achieve carbon neutral or net zero. The second concept, we need to consider life cycle assessment as a basic, as a start. Now, how do we do that? Now, naturally, you think about, what is the contributions of emissions, right? So you can name all of them, from your right to left. Basically, if we could reduce waste, reduce water. I use this term just now, embodied carbon, right? Those carbon embedded in the supply chain because of material use. Renewable energy, obviously, instead of fossil fuel. Reduction of energy, so energy efficiency measures, as well as the whole planning. So through plantation, through greenery, how to reduce the temperature, therefore reduce the design temperature of HVAC system. HVAC basically, more than 60% of the energy consumption within the building. So by reducing the surrounding area's temperature, we can actually achieve less carbon emission within the building. So all of these contribute to carbon reduction. So with these in mind, I don't want to scare you by a lot of distilling figures, but I would like to explain a little bit the importance of some figures. Now you recall, the beginning of the graph, the early graph, you recall the red line, right? So if the supply side and demand side, so supply side meaning not us, CLP, Hong Kong Electric, so those utilities company, if we do not do anything, both supply side and demand side, basically we will have the red line. So from 2030 to 2050, so red line meaning, we do nothing. And then of course, our friends of CLP, they say, we already commissioned following policy. By 2050, we will reduce our supply side emissions. So if we even do nothing, right, we can still enjoy the reduction from the supply side, because we use electricity, and the electricity, basically the supply side, they already decarbonize gradually, from time to time. So now we have the purple line, right? The purple line basically is reductions by CLP, right, from the electricity company. So, but we do not only rely on supply side, we have to demonstrate by doing a lot of things to push the boundary in demand side. So meaning we engineers, we architects, we structural engineer, electrical engineer, mechanical engineer, building service engineer, we need to achieve collectively by doing something in the demand side. So the blue line basically represents the green deck design. So this is the design case that I just talked about. We, based on the design case, incorporate appropriate measures at this point of moment. With all these collective measures from structural architectural and also E&M, we can collectively reduce our carbon by 29%. Now, what does it mean by this figure? 29% meaning from the baseline 2030, reduction of 29%. Now, this figure, again, is quite scary if we talking about, basically, this is the baseline 2030. But if we refer to the baseline 2020, so you imagine in 2020, the red line, if we do nothing, is even higher, right? 2020, right? Even higher. So the reduction percentage, if we use 2020 baseline, is 50%. So as a rule of thumb, you imagine every 10 years. Now we are in 2023. So in 2030, basically we need to reduce not only PolyU case, but every person as a city as well, we need to reduce by half in 10 years time. And similarly in the coming 10 years and the next 10 years. So every decade we need to have 50% of reduction to achieve this point at the end. It's a very drastic and very challenging. So how come I just asked you in 10 years time, you reduce your consumption in eating? Huh? So this is quite challenging, as a whole. Now, this is what we need to do. It's basically unprecedented request in human history, basically. Well, we need to reduce by half in a decade. Now, this is the importance. And also, this is something that we need to know. At the end of the day, it's not only zero. Some of the science-based target for companies, they also need to achieve even positive sustainability, meaning negative carbon. So you see the figures. Well, of course, now in planning stage, so on paper, through our calculations, through our assumptions, basically in operational stage, through our standard design case, we can achieve minus. Why minus? Because we already incorporate, at least in this moment, some greenery, some plantation, which can absorb carbon. And by that time, in 2050, CLP already achieved their carbon neutrality. So we assume on the supply side, our friends in utilities company, they can also equally achieve carbon neutral. So both demand and supply side, they can reach this point. And as a whole, we can achieve even better than zero carbon, right? Some of the key concepts that I would like to explain again to you upfront. Now, I won't explain every figures here. Now, the previous slide basically explained the operational carbon. Now, this slide further explained to you on embodied carbon. So we call the term upfront carbon and also operational embodied. So this is something that we can also calculate at least on paper at this current moment. Upfront embodied, operational embodied, and the purple, and then we are considering the design case. And I will just in a minute further explain the ambitious case. But just bear in mind, also we need to consider the whole life. So this is the total carbon emissions from 2030 to 2080 actually. So the accumulative, the total amount of emissions on the embodied carbon case. And again, in terms of the percentage split between the upfront operational and operation carbon, so here are the total figures. Now, why we need to calculate these numbers basically means nothing to you, right? But a lot of now the C-suite, the board of directors, they are quite concerned about this number. Why? Why? Because they need to know as a whole how much they need to invest as an organization if they really want to take it seriously before 2050. Meaning, say, oh, I want to achieve zero carbon in 2030. How much I need to pay as a company to offset this carbon in its corresponding year? Now, this is the cumulative, but as you know, if we want to achieve carbon neutral before CLP reaches zero, there's quite a lot of numbers. I mean, quite a lot of amount of carbon we need to offset by actually paying money to offset, buying carbon credits, etc. So this is the number that a lot of, at organizational level as basically as a backup plan if they want to achieve earlier. Now, sorry for the busy slide, but just want to let you know from this point and above. I have more sorts of more figurative slides after, but just quickly, I will just let you know what have been incorporated in the basic design. So from this point above, we say adopt in design, right? Adopt in design. So basically the top 20, including mechanical measures, landscape tree planting, light power density decrease, passive design, renewable energy, recycled materials, etc., etc. I'll explain furthermore in a minute, right? And also water and waste, as I explained, the key categories that we need to address. Now, a lot of things in ambitious case, we suggest that we need to keep in view in order to further achieve a better or more ambitious reduction. So mainly on embodied carbon and some behavioral change, in the coming future. Now, I'll explain a little bit or share with you a little bit more what are the major design features behind. Number one is about in urban area, we need to address urban heat island. It's not new to us, but basically, as I explained, when we have the hard pavement and concrete surface, we need to reduce the surface temperature by planting shrub and trees and all this landscape. And then, of course, we run the thermal model and achieve a reduction on temperature. So comparatively speaking, on the baseline, if we do nothing, basically it's 3.29. And then we reduce by 2.16 degrees Celsius. It's quite a significant drop if we really, plant all these species on the landscape stack. Now, there are two implications here. One is by reducing this number, the outdoor temperature will reduce. And therefore, as I explained just now, the HVAC system, the burden will be decreased as well. So meaning the energy reduction. The second thing, of course, we talk about a lot of comfortness around the area. Of course, this is one point, but I would like to also mention one point is about the climate resilience on this. Now, the thermal comfort, yes, this is beneficial. There are a lot of research talking about the correlation between the increase in temperature and also the wing pattern above. So you see a lot of intense rainfall. I haven't included in this slide, but just basically I just tell you a little bit more. A lot of intense rainfall in city area is due to urban heat island effect. So not only comfort for people, but also for urban drainage or to the benefits of urban drainage, because a lot of correlation between increase in temperature in city area basically affects the pattern of rainfall in city area. That will also contribute to more intense rainfall in the city area. Now, so this is something that I would like to share. And secondly, of course, as I mentioned a lot, embodied carbon. So a lot of opportunities for us to explore more on sort of new advanced materials. And we already talked to, a lot of your professors like Professor Poon, Seth Poon, and quite a lot of new ideas that he shared with us on the new use of materials along with Construction Industry Council. So there's a certification system behind the council, a lot of push the boundary selection of new materials like here. Now, just the big picture is that the embodied carbon and structural materials and the MEP materials, the comparison. A lot of embodied carbon basically embedded in our materials on structural. So basically steel, sand, cement, concrete, etc. And so here you see some key examples. If we can do, well, even the top four, so pulverized fire ash with 25% for replacing conventional cement, recycled materials 60%. Here's the production through not conventional furnace, but electric arc furnace by producing steel. You can imagine there could be a lot of steel works, the structural steel form to support, to underpin the deck. So a lot of materials here contribute to embodied carbon and of course certify green product, for example, timber and upcoming maybe bamboo for some non-structural support. Now these collectively, if we adopt, these already adopted technologies could help us to achieve around 30% or even 40% of the embodied carbon reduction. Now, here's still the design case. I haven't talked about the ambitious case. Now, I just mentioned about the CIC. The system already set up. So a lot of product already certified in terms of here, RMC, reinforcing bar, and some paints and coatings. Some commonly used materials already proposed, certified by CIC. So the authority basically encouraged us. They already had got the EC, embodied carbon database, and some local exemplars. So basically, we will adopt in our standard design. And of course, some other highlights are the use of renewable energy. Of course, it will be subject to the space constraints. Territorial level, the government is set out a target overall from 10% and ultimately to 15% by 2050. And here, of course, we need to harness all of our space if possible, to incorporate renewable energy right across the whole area. So here are the key areas that we propose in the design stage. That could be more, down down to the detailed design. Another key highlight, I talk about trees in the beginning, right? Plantations in the beginning. Now, the current design, we already adopt 400 numbers of trees. Now, the key thing is that, do you know how much carbon can be absorbed by a tree per year? Now, I'll just give you an example, not an example, basically it's the fact. Every person, you and I, emit in average Hong Kong 4.3, let's say we just round down to 4 tons per year per capita. So how many trees you need to plant to offset these 4 tons? Do you know how many trees? Yeah, the answer is 160. 160. Why? Because one tree will absorb per year, in average, around 25 kilogram. 25 kilogram. So 4 tons, 4,000 kilogram. So 4,000 kilogram divided by 25, right? It's 40. No, sorry, it's 160. So 1 ton, 40 number of trees. If you have 4 tons, 160 numbers of trees. So you imagine one person, you just offset your carbon per year. You need to plant 160. How many trees in PolyU now? I don't know, but it's a lot. It's a lot. So you can imagine even 1 ton, we have to have 40 number of trees. But now, just theoretically speaking, for trees, 25, I'm going to, have another type of research. It's about the carbon removal of different species of trees. So the major highlight here is that in terms of landscape design, in addition of beauty and aesthetic, we also think about the functionality of the trees, that is carbon removal. And here the left-hand side shows you the different species of tree basically have different extent of carbon emissions. So simply speaking, the bigger the tree, the more the carbon removal capability. Right? Bigger the tree, not this size. Basically, it's talking about more than 400 millimeter diameter of this type of tree and more than 4 meters. Right? So more trees, a bigger size the tree, the more carbon absorption capability. So we're actually designing appropriate species, of course, together with other landscape design consideration. But actually, we use this approach to dynamically to understand the tree absorption capability and try to implant the right mixture of trees to achieve a higher level of carbon emissions down the road. Now, this strategy has already been considered by the government in the public project, because it's not just a fixed number, 25 kilogram, more than 4 meters height of trees. No, trees basically is an organism. It is growing. It is growing. And then strictly speaking, if you need to plant a tree, every year you need to track its growth rate. The higher the growth rate, basically the more absorption it can be, just like people, right? It absorbs CO2, store the C, carbon within a tree, release the O2, photosynthesis, and then grow. So the younger the tree, the higher the carbon absorption because of its younger stage, and then it will decay when it is aging. So strictly speaking, I'm talking about strictly, we need to treat it seriously, talking about carbon credits. If we buy a forest in Indonesia, at some point you need to decommission a tree because it's in that age in order to actually achieve the actual number we want to achieve. Now, a bit further, what I'm just talking about is related. It's related. So we need to consider in this level of granularity in order to demonstrate more our advanced thinking. How much time do I left? What's time? 54. Okay. Now let's move on. 3 minutes more. I just finished the design case, and one more case is that by assumption we can also reckon more futuristic, more ambitious adoptions of carbon measures. So very briefly, from our baseline to energy efficiency design, the key message of this slide is just pay attention to this word, super low energy design. Now, you recall that average building, even we achieve, in Hong Kong, we have the platinum, we have the BIM system, just like LEED system in the US. Even we achieve platinum in our building design, it can only cater for around 30, at most 35% energy reduction. Now it's talking about super low energy building, 60% versus even the platinum, the highest. So even 25% more reduction from the baseline. So we are putting, this number in the ambitious case as a challenge for, us, in the coming future. So what will be incorporated? Now, conceptually, we need to have more ambitious facade, so for passive design, more stringent, more aggressive OTTV, thermal performance of our wall or our facade, much improved system design, talking about, water side, air side, the HVAC system, more energy optimization through AI or machine learning, and also more digital solutions, basically the real-time back and forth, dynamic control, behavioral change. Now, just give you a little bit more in terms of both embodied carbon and also active design. I mentioned about the typical or already adopted CIC or some of the industrial product on typical construction materials. Now we can consider a little bit more or more aggressive or more high percentage of adopting timber or composite timber structure and bamboo. Of course, we also need to push our authority to have this incorporated into their compliance checking. But this is something that we can consider even or as a start for non-structural elements in the design. And I mentioned a bit on behavioral change. How can we actually achieve super low energy building, the remaining 20%, so 60% as a whole. So a lot of these collective measures, including more dynamical, more IoT and controls optimizations real time. So I'm sure that in this stage, know a lot of, or at least you hear a lot about it. Carbon emissions tracking and optimizations, basically back and forth and real time tracking for personal energy use. So behavioral change as well as energy storage. So optimization between energy. For example, during lunchtime, your energy can be stored in battery and then released in the peak time, something like that. Now, from research perspective, the behavioral change actually can help around at most 15%. So you see the third paragraph. So some of the research suggested ranging from 5 to maximum 15% in terms of behavioral change if we adopt the measures that I just shared, right? And a lot of campaign as well, at organization as people engagement and more dynamically interaction. So a lot of campaign competitions on resources use and resources circularity can be achieved through this means. Now I will jump this line. Basically, in the ambitious case, we can further achieve by making use earlier of those ambitious measures to 80-something%. And similarly for embodied carbon. Now this is basically the end of this line of this part. Again, the figures to you may not be most significant, but what I try to push is basically the advanced measures that I just explained. This one, I think I would just, in a minute, I'll finish it. The air purification system basically is an active system that will draw energy will draw energy in the tunnel. We need to do it anyway because of code compliance from our EIA and also environmental protection, EPD. Now we need to do it. But actually, we also need to have some kind of what we call adaptive approach to this design because, everything basically is changing, especially the traffic pattern and also the type of vehicles. So I just draw attention to the safer example. Here is the vehicle type on your left-hand side. And the increasing use of electric vehicle basically will actually help us to reduce the burden of air purification system. So in day one, this design is X, right? But maybe in 10 years' time when it is refurbished or replaced, so we need to have some adaptive approach to actually design the system on the one side to meet the current standard requirement, but on the other side, we need to consider the future adoption of, for example, electric vehicle. We need to have this incorporate, the flexibility incorporate in the design. So here basically some comparison with and without the air purification system and some dynamic, the change of the number down the road. So I'll jump this as long as you grasp the concept. Rather, go to Q&A given the time. So thank you very much. Hope you are with me so far. Thank you.
Thank you, Dr. Bruce John Sterling. I trust we have learned a lot in his presentation. Now we will go to the Q&A session, and may we invite Mr. Alex Lowe and Dr. Bruce John to sit in front to address some questions from the audience. So for people joining by Zoom, please feel free to type your question at the chat box. And for in-person participation, please raise your hand and we will pass the mic to you. So any question? So maybe I oh, okay, the red coach.
The big tree on the top level, because the loading of the soil and also the plant, if the tree go up, that would be a big problem about the typhoon, and also about any other problems we have to maintain. For example, the pest control, something like that.
Thank you very much. Our landscape designer has come up with a very good design where there's a mix of different maturity of trees, but definitely there will be some large trees there. It can be done, I think, technically. If you just walk through our PolyU campus, if you look in front of that M block, Lee Ka Sing building, there are some very mature trees there, very big, very large, and that can be done on a deck. So we have allowed for the loading. We know that bigger trees would need a bigger bulk of soil in order to keep it alive. That has been included in our design. Yeah.
Just give you one idea, because we're talking about carbon. So in theory, in terms of carbon removal, about trees basically represent globally 60% of carbon emissions, whereas below ground the soil around 40%. Soil also matters. If we talk about, strictly speaking, carbon removal. And of course, we need to strike a balance because of structural, and as this gentleman mentioned, strike a balance in terms of engineering or architectural design for big, small shrubs. But basically, theoretically speaking, both accounts for a big chunk of removal from carbon perspective.
So any other question? For people attending by Zoom, please feel free to type your question on the chat box. Okay. Yeah.
Material selection in your construction so as to reduce the embedded carbon. Any particular consideration or what kind of construction material you'll be using in this project?
Well, the typical examples in design case that we can adopt, at least following common industrial best practice, PFA, 25% cement replacement, and recycling sand and aggregate, in some non-structural elements for the platform, as well as the steelwork using electric arc furnace. Now, these are the typical products or materials that are used for the project. And so this is for the design-based case that we can at least adopt. And also some others potential, as I mentioned, composite wood or bamboo for some non-structural parts can also be incorporated. Now, so this is one side on the active control of using these materials. I think in the upcoming future, unavoidably, we need to sort of set up a continuous measurement, like, or in this stage, at this at this stage, well, we can achieve like 20 to 30% of reduction in average on reduction and body carbon. Now, in the upcoming stage, when we have more adoptions of this advanced material, we can, I think, take an active role in advising like CIC. They still, adopt, passively what can be done in the industry and using some local materials, local information to calculate the embodied carbon. But I think, as from a research upfront, we can also, counter propose some sort of new materials and incorporate into our measurement system.
Dr. Chong, you talk about behavior change. So what's the view about the COVID-19 impact on the behavior change of people? Like people have more takeaway, eating at home and work from home. Are you expecting an increase or decrease in the carbon production?
Well, short term, I think will be increase because the revenge of no consumption before. I mean, you see a lot of people last weekend. I saw a lot of people on the street shoppings, and I see in the short term even the consumptions on all. But I think this is something that we need to take into account in the long run. I think the innovation or technology could help to sort of monitor or advise people's or even change the behavior of people. And of course, it can't be just technocratic. Or people, there needs to be so characteristic. I mentioned when we set up the digital system, some other measures need to be in parallel, like incentivization of those who actually take active role in achieving more carbon reduction, some competitions or some programs, some campaign to drive people or drive a department, drive a section, drive a business unit to achieve all that. This is quite commonly or already adopted in as organizations. A lot of companies, they find difficulties in pushing people doing something good. It's not just for the sake of, I want to save the environment. It's not just like that. We need to, push and encourage both sides.
Dr. Chong, may I just add my own observation? I think in the short term, I think the behavior of human beings at the beginning of this, there will be a long adjustment period because all the buildings were built before the COVID-19 came to affect us, right? So it would change our lifestyle because of that, and we have to. There will be a lot of wastage anyway. The space that will be created for large meetings, that there will be no more meetings required because you cannot do that anymore. So there will be wastage like that. I think that's pretty hard to avoid. But over a long period of time, I think we might be able to achieve a better balance to catch up with the new requirements of our new behavior, taking into consideration of the similar kind of disease like COVID-19. But I do have another question for Dr. Chong. I'm more interested in the cost of construction. I know that you talk about the lifetime cost of the carbon or no carbon issue. But if I do not do anything, but I do not follow the business as usual bar, I just follow that China-like kind of curve coming down there, but I won't do anything myself to improve that speed of reducing carbon emission. What do you think the difference in construction cost would be for an average building, say a residential building?
We did a study for Hong Kong GBC during the time of adopting platinum, those green certification systems. Some ballpark figures during that stage by incorporating, at this stage, new measures or advanced technologies to achieve platinum, talking about around 8 to 10% increase in construction costs. But you can get the payback because of operational cost reduction. So you can, down the road, offset, by gaining more, reduction on OPEX. And similarly, if I would just by analogy, now if we incorporate, I just mentioned super low energy building and advanced materials, I think it's I don't want to have sort of a number, but I think it's about how we collectively create a market for adopting these new technologies. So when we use the materials and take lead of adopting these materials, because we have less, I think, less constraints, comparatively speaking, as other government or those projects with more constraints or legislative. Of course, we are also subject to legislation, but I mean, as a research or from PolyU side, I think we have more flexibility to adapt all this. So we can create a market, and if we change this as sort of a business as usual adoption, just turn it into more normal use, I think we can get the sort of get the advantage of being the advanced or early users of these. And of course, another point I would like to point out is around transition risk that a lot of companies mention about. So transition risk, meaning when we are moving towards carbon neutrality, we will face a lot of risks. So not only technological risk, but also marketing risk, reputational risk, and also policy risk. Say, for example, if we were in one of the cities in mainland, and suddenly there's a policy saying, oh, you need to have 50% of renewable energy next year. And well, at that time, we only have nothing be incorporated. And then in 1 year's time, you need to incorporate 50% or else you will be penalized, something like that. So, well, we need to have this in mind, putting into the shoes as an organization, being questions and queried and even criticized on ESG.
Okay, now I'd like to pose to you another question. You show us the graph of all those sloping lines, right? But they all end up at the same point. Yeah. So why should I spend more money up front? At the end, I would just end up at the same place.
It's a very good question, because the later you do the reduction, the more expensive of carbon credits and also carbon offsetting you would have, because the CLP basically they already reduce a lot, and then you cannot and then the every unit of carbon you need to reduce, basically you need to have more renewable energy to offset it.
I don't plan to do any carbon offsetting. No, I'm very happy with ending at that same spot there.
Yes. Yeah, I know. So at the end, ultimately, we'll have the same result, sort of passively, we'll probably have the same result. And it will go back to the point of transition risk argument. Well, the economists, this issue just now, they have a passage, an article explaining, well, there's an analyze, I just quote a term, they call it in the US, from company perspective, there's a movement, anti-ESG movement in 2 states, one in Texas, one in, I forgot,
California?
No, California is not Republican. So, sorry. Another state in the middle state. They push anti-ESG code. What they actually put behind is that, okay, for all investors, you cannot consider ESG for determining buying your, a portfolio on behalf of your client. Now, why do I mention this? It's because, as I mentioned, transition risk. Now, you are saying that, oh, we can, forget about everything because someone can do it for us, and passively, we can also achieve ultimately the target. Now, you need to remind that the governance level or the C-suite, they will, they will face 2 dilemmas. Do they need to consider ESG as part of their projects or the selection of materials or procurement? If they don't, the argument in the article is that the government, they put forward anti-ESG rule, but ultimately the penalty of all the processing costs and also the sort of unsatisfaction from bottom up. So people, the taxpayer, they are not, really, for this kind of I don't know, is
Yeah,
policy. You get it? Yeah.
I'm sure that you have a very good reason for saying what just said. Why I'm asking you this, I'm really asking for help because as architects, we have to face our client. The client don't want you to spend so much money.
Yes.
So I end up at same point, and you want me to spend 8% more
yeah.
money to build my building. We need some good argument, very simple
Yeah.
and very convincing, and without going into too deep a kind of explanation to them.
Yeah.
I think that would be very helpful to
I
us.
fully agree. Now, that's why we divide into operational carbon and embodied carbon. I fully agree that on embodied carbon is kind of, upfront investment. We need to steer where all the goodwill is, steer research, Yes, it takes time and cost and needs more explanation why and more intangible reason, right? Intangible benefits. Now, more tangible benefit of it easier to explain operational cost because of reduction on resources, energy, water, waste, and easier to get the payback by renewable energy and also energy efficiency. I fully agree. But at least, or bottom line, operational carbon we need to achieve a bigger amount of reduction. Yeah. But for embodied carbon, we can further explore how to further persuade. And
Thank you, Dr. Chong.
I think this topic is very interesting and we can still have a lot of talking over. But because we are running out of time, may I check if any other people have, okay, maybe we answer the last question from that lady. Yeah, first.
Thank you for your brilliant idea and wonderful sharing. I think this green deck is very beautiful. I'm thinking that it might be the next attraction for tourists. I've heard that this place, in the traditional version, we can accommodate 500,000 people. But what if it become a new attraction and attracting more tourists or other residents to here? I'm wondering what's the maximum carrying capacity of this green deck? And how do you have any solutions to the overcrowded situation? Thank you.
I love the green deck to be overcrowded. I think the garden, the park is an open place. There's no roof, right? So it's just like any other open ground. You can gather as many people as you like on the open. So I don't think there's a very important concern on overcrowding it. Perhaps the overcrowding could be a problem for the structural engineers. If too many people kind of get onto the deck itself, as long as the structure is strong enough, I think that would be fine. I mean, we have allowed assembly of large crowds of people, not on the entire deck, maybe on certain part of the deck where there's some event, some event is ongoing. It will attract more people to go over there. I think that's one of the way to use the deck, right? Because it could be used for several events at the same time. So overcrowding, I don't think that would be really a big problem, as far as I can see.
Okay, thank you, Alex and Dr. Bruce John sharing today. So the event is about come to end. Thanks for all the participation. Grateful you can complete the feedback form on the screen with so loud so that we can know more about your views on Green Deck. Your views on Green Deck are very important and we sincerely hope to meet and listen to you again soon. Have a good day. Bye. Okay.